Hello, this is John Purcell from quantumlifetime.com, and in this tutorial we're going to look at polarized light. Now, I thought it would be interesting to look at a real-world example of quantum mechanics before we go on to looking at the mathematics of quantum mechanics, and so for that reason I want to spend a little bit of time talking about light and photons. Light, as you may know, is a transverse wave, so that it has a kind of vibration to it that's at right angles to its direction of travel, and that stands in distinction to something like a sound wave which vibrates along its direction of travel. Light is more like the waves on the sea, which are also transverse. They go up and down, or the waves on a piece of string if you hold one end still and wave the other up and down or from side to side. Now, the direction of vibration of a light ray is, we call it the direction of polarization. And a normal ray of light consists of lots of short pulses of light that have all kinds of random directions of polarizations. There's such a thing as a Polaroid filter, and a Polaroid filter, which I'll represent like this, will only let light through that's polarized in a certain direction. So let's imagine that there's a ray of light that's coming from behind you, and it's heading in a straight line directly over your shoulder and directly into the screen. And imagine that it's passing through a Polaroid filter that's sitting on your shoulder. The light that then emerges from that filter is going to be polarized. If the filter's oriented this way, the light that emerges is all going to be polarized in this direction. It's going to be vibrating up and down in some sense, in other words. Now let's imagine that you've got a second filter. So this ray of light, which is, remember, it's heading directly into the computer screen, but I'll draw it kind of sideways here. So we're imagining that it's passing through two filters, and we're going to imagine that it's going first through this filter and then through the other filter. These are Polaroid filters. Now what happens if the second filter is oriented in the same direction as the first? So the first filter is oriented this way and the light is then polarized this way, and imagine that the second filter that it passes through, which is just in front of the first filter, is also oriented in this direction. And you can actually try this for yourself if you break a pair of Polaroid sunglasses in half and you look through both lenses at the same time, and you can try rotating one lens relative to the other lens. So this is the first case where the second Polaroid filter is oriented in the same direction as the first, and in that case all of the light will get through, will have 100% transmission. Supposing we take a second case where the second Polaroid filter that the light passes through is oriented at right angles to the first, so the light's going like this and the Polaroid filter's this way. In that case we'll have 0% transmission, at least in an idealized world. And in the third case, which is quite interesting, supposing the light's oriented this way after passing through the first filter, and the second filter's now at 45 degrees to the first filter, in that case we get 50% of transmission of light, so only half of the light will get through that filter. And this is all in the realm of classical mechanics. So we're making observations about the light, and we're saying we've got light that we've now found to be polarized in a particular direction, and then we're making a second observation immediately afterwards that's a different observation, at least in these cases, to the first, and we're making concrete predictions as to the intensity of the light that then gets through that second filter. Whereas we're going to find in the next tutorial, when we look at photons, that in the realm of quantum mechanics we end up talking about probabilities instead of being able to make concrete predictions. And it's going to always be the case if we make the same observation twice. For example, we put light through a filter that's oriented in two filters that are oriented in the same direction, that we can make a concrete prediction about what's going to happen, even in quantum mechanics. It's when we make two different observations with a filter, for example, being oriented this way and a second filter this way or this way, that things can start to become a little hairy. So that's it for this tutorial. Join me again next time, and until next time, keep it real.